Hey everyone, here's a nice little problem that I like, integrating a piecewise defined function. It's number 25. I think it's the last one in this section 5.4. We're going to evaluate the integral of the function little f from -1 to 3, where little f is a piecewise defined function, right? The output is determined by this rule if x, the input, is less than or equal to 1, and basically squaring the input if the input is greater than 1. So depending on the input, we have a different rule. So basically integrating here, notice for values less than or equal to 1, we have to use this rule. So from -1 to 3, we go from -1 to 1 using this formula, right? And then, right, from 1 to 3, we would have to use this formula, right? So again, if I graph this function for values from -1 up to +1, then it would the graph is the function 3 minus x cubed. For values greater than 1, the graph is the parabola x squared. So that's how we can do that. Don't have to graph the function. You might want to visualize what's going on, but now we just do the fundamental theorem of calculus part 1 on each one of these. So it's pretty easy to find the antiderivative here. Antiderivative of 3 is 3x. Antiderivative of x cubed is 1/4 x to the fourth. And I'm going to evaluate it at 1 and plug in x is -1, so be careful there. I get -3, but -1 to the fourth is still +1, so I get -1/4 there. And then the antiderivative of x squared is 1/3 x cubed. Plug in 3, I get 9, right? Because 3 squared is 27. 27 times 1/3 is 9. And plugging in 1 gives me 1/3 and subtract. Now I just need to simplify these and proceed. Notice here I got 3 minus -3, that's 6. And -1/4 minus plus 1/4 is 0. So literally this whole thing is 6. Okay, 6 is the evaluation of this, basically this first integral. And then 9 minus 1/3 is 27/3 minus 1/3, or 26/3. All right, combining these as one fraction gives you 44/3. And of course, that's the result for this problem. Okay, hope this makes sense. Nice little problem.